High above the German capital on the 6th of March in 1944, American fighter pilots were about to demonstrate something that would fundamentally change the nature of aerial combat over Europe. 28,000 feet up, where the air grows thin and engines strain for oxygen, the 56th Fighter Group found themselves tangling with Luftwaffe interceptors in what historians would later recognize as one of the largest aerial engagements the European theater had witnessed to that point. The German pilots, veterans of years of combat, executed the same maneuver that had saved their lives countless times before. When pursued by the heavy American Thunderbolts, they would simply pull back on their sticks and climb. For 12 months, this tactic had worked with near-perfect reliability. The massive P-47, weighing in at 7 tons when fully loaded, simply couldn't maintain pursuit angle when a nimble Messerschmitt or Focke-Wulf pointed its nose skyward and clawed for altitude. Except today, something was different. The American fighters refused to fall away. They stayed glued to the tails of the German machines through climbs that should have broken contact. As both groups of aircraft approached the edge of their performance envelopes, with airspeed bleeding away and controls growing mushy, the Thunderbolt pilots squeezed their triggers. Dark smoke began streaming from German fighters as pilots abandoned their stricken aircraft. When the mission concluded and pilots gathered for debriefing, the tally was shocking. 11 German fighters confirmed destroyed, not a single Thunderbolt lost. The transformation that had been months in the making was now complete. A seemingly simple modification to the propeller had eliminated the most glaring weakness in the Thunderbolt's combat repertoire and fundamentally altered the tactical equation in the skies over occupied Europe. This transformation began during the bitter winter months of 1943 in the engineering offices of 2 American companies that specialized in propeller design and manufacture. While bomber crews continued to suffer horrific losses over German industrial targets and fighter pilots submitted after-action reports describing enemy aircraft simply climbing away from pursuit, engineers worked frantically to solve what appeared to be a straightforward problem. The Pratt & Whitney radial engine mounted in the nose of every Thunderbolt generated 2,000 horsepower, an enormous amount of power by any standard. Yet the aircraft climbed poorly, sluggishly, inadequately. The culprit was the narrow-bladed Curtiss electric propeller bolted to the front of early production models. These blades had been optimized for a specific flight regime, designed to slice through air with minimal resistance at speeds exceeding 350 miles per hour. They were remarkably efficient at high-speed cruise, exactly what you wanted for a fighter escorting bombers deep into enemy territory. But during climbs, when airspeed drops and the engine runs at maximum power, these narrow blades simply couldn't grab enough air to convert all that horsepower into vertical thrust. The engine would scream at maximum revolutions, consuming fuel at an alarming rate and generating tremendous heat, but the aircraft wouldn't pull upward with the force needed to stay with climbing enemy fighters. In January of that year, at Republic Aviation Corporation's headquarters on Long Island, Alexander Kartveli spent long hours reviewing combat reports filtering back from England. The pattern was unmistakable and deeply troubling. German fighters would dive through the bomber formations, make their firing passes, then haul back into steep climbs. The pursuing Thunderbolts simply couldn't follow. Performance data made for grim reading. The early P-47 variants took far too long to reach the altitudes where combat typically occurred. The Focke-Wulf 190A and the Messerschmitt 109G reached those same altitudes much more quickly. This wasn't just an academic performance gap. It was being measured in American lives. Pilots were dying in situations where better vertical performance might have given them the edge they needed to survive. Some commanders within the Army Air Forces were beginning to question whether the Thunderbolt should continue flying frontline missions or be relegated to less demanding roles. Kartveli understood the engineering problem with clarity. Propeller efficiency is all about matching blade characteristics to the conditions you're operating in. Narrow blades work beautifully at high speeds because their thin profile creates minimal drag as they spin through the air. But at low speeds during climbs, you need more surface area to bite into the air and transform engine power into forward thrust. Increasing blade area seemed like an obvious solution, but the reality was considerably more complex. Every change to propeller design ripples through the entire aircraft system. Get the blade shape wrong, and you could create vibrations that would literally tear the engine from its mounts. Improper weight distribution might generate harmonic frequencies that could cause catastrophic structural failure of the airframe. Incorrect torque characteristics could make the aircraft uncontrollable during critical phases of flight, like takeoff. Republic Aviation needed propellers with significantly larger blade area that could be integrated into existing aircraft without requiring extensive modifications to the airframe or systems. Two companies entered the competition to develop this crucial upgrade. Curtiss-Wright, the manufacturer of the original narrow blade design, and Hamilton Standard, a company with extensive experience producing propellers for various military aircraft types. Both engineering teams understood what was at stake. The winning design would be manufactured in quantities exceeding 10,000 units. More critically, it would directly influence survival rates for thousands of American pilots flying combat missions over occupied Europe. Engineers at both companies worked through the winter of 1943, conducting extensive wind tunnel testing, calculating stress loads on blade structures, fabricating prototype hub assemblies and pitch control mechanisms. Men were dying while engineers refined blade chord lengths and calculated optimal twist angles. The engineering team at Hamilton Standard developed an approach that represented a significant departure from conventional propeller design philosophy. Instead of thin knife-like blades that sliced cleanly through the air, they proposed wide, paddle-shaped blades that would grab the air more like oars pushing through water. The blade chord would increase dramatically. The blade shape would be nearly rectangular for much of its length before tapering near the tip. To engineers trained in traditional aerodynamic principles, this design looked crude, almost primitive. But wind tunnel testing revealed remarkable characteristics. The design generated substantially more thrust at low air speeds while sacrificing only minimal performance at the top end. Curtiss-Wright responded with their own wide blade design that maintained a more traditional elliptical blade shape while dramatically increasing the overall area. The Curtiss design incorporated blade cuffs at the root that smoothed airflow into the propeller hub and reduced vibration. Both designs represented massive improvements over the original narrow blades. Republic Aviation received prototype propellers from both manufacturers in April of 1943. Testing commenced immediately at Republic's own facilities and at Wright Field in Ohio. Republic's test pilots methodically evaluated both designs across a comprehensive matrix of flight conditions. The testing revealed that both the Hamilton Standard and Curtiss propellers offered nearly identical performance improvements. Climb rates improved dramatically with either design installed. The Hamilton Standard offered marginally smoother operation thanks to its hydraulic pitch control system. The Curtiss design integrated somewhat better with existing aircraft systems and would be easier to retrofit onto P-47s already serving overseas. Neither design was clearly superior across all evaluation categories. The Army made a pragmatic decision driven by manufacturing capacity considerations. Both designs would be approved for production. Hamilton Standard propellers would be fitted to new P-47s rolling off the production line at Republic's Farmingdale facility, beginning with the P-47D-22 model. Curtiss paddle blade propellers would be fitted to P-47s manufactured at the Evansville factory in Indiana and would be supplied as retrofit kits for earlier aircraft already deployed in England. This decision prioritized rapid deployment over standardization, but manufacturing challenges and testing delays meant the first operational aircraft didn't reach England until late December of 1943. Throughout that final month of the year, P-47s were ferried to RAF Wattisham, where mechanics worked around the clock retrofitting them with the new propellers. The 56th Fighter Group, operating from their base at Boxted in Essex, completed their transition by early January 1944. The group commander, Lieutenant Colonel Hubert Zemke, immediately grasped the tactical implications of what his pilots now had at their disposal. The dramatically improved climbing performance meant his pilots could engage German fighters using vertical tactics that would have been suicidal with the narrow blade propellers. Zemke organized intensive training throughout January, developing new combat procedures specifically designed around the paddle blade Thunderbolt's enhanced climbing capability. He taught his pilots to engage German fighters in climbing spirals, maneuvers that previously would have left them vulnerable and slow. He developed techniques where pursuing P-47s would pull up sharply if enemy fighters attempted to climb away, converting speed into altitude, then diving back onto targets with accumulated energy advantage. With narrow blade props, these maneuvers would have left Thunderbolts wallowing at low speed, easy targets. With paddle blades, they became deadly offensive tactics. The 4th of January 1944 marked a significant milestone. The entire 56th Fighter Group flew its first mission with all aircraft equipped with paddle blade propellers. Pilots immediately felt the difference. The aircraft climbed with an eagerness that seemed impossible for 7-ton fighters. Energy retention in vertical maneuvers improved dramatically. Thunderbolts could now follow German fighters into climbing escape maneuvers without losing position. The real test would come when they encountered the Luftwaffe over Germany. Combat debut came during escort missions in late January and early February. American fighters found themselves in situations where German pilots executed their standard escape tactics, only to discover pursuing Thunderbolts matching their climbs. Initially, German pilots assumed they were facing a new American fighter type. When intelligence officers examined gun camera footage clearly showing standard P-47 Thunderbolts achieving this performance, confusion rippled through Luftwaffe units. How could the same aircraft they had successfully evaded for months suddenly match their climbing performance? The 6th of March 1944 provided dramatic confirmation of the transformation. Lieutenant Colonel Zemke led 48 Thunderbolts on bomber escort to Brunswick, routing over Berlin. Luftwaffe controllers vectored more than 80 Messerschmitt 109s and Focke-Wulf 190s toward the incoming bomber stream. As the bombers approached at 24,000 feet, German fighters attacked using their standard tactics, diving through the formations, then pulling into steep climbs to escape the escorts. Across the sprawling battle, Thunderbolt pilots matched German fighters in vertical combat for the first time. Captain Robert Johnson, Lieutenant Walker Mahurin and other pilots from the 56th Fighter Group caught German fighters in climbing engagements and destroyed them at high altitudes. The group claimed 11 victories without losing a single aircraft. More importantly, not one bomber in their assigned formation was shot down. German pilots landing after the Brunswick mission reported disturbing developments to their intelligence officers. American Thunderbolts were climbing with them, staying on their tails through maneuvers that should have broken contact. Multiple pilots insisted they must have encountered a new fighter type. When shown gun camera footage depicting standard P-47s achieving the described performance, confusion deepened. Luftwaffe technical intelligence needed to understand what had changed. The first clue came from wreckage analysis in early February. A shot-down P-47D-23 was transported to the Luftwaffe test facility at Rechlin. Engineers examining the aircraft immediately noticed the propeller blades were far wider than those on previously captured Thunderbolts. The technical intelligence report described the new design, but initially failed to grasp its significance, concluding the modification likely improved takeoff performance rather than combat capability. This misunderstanding cost the Luftwaffe valuable time to develop countermeasures or adjust tactics. Throughout February, more P-47 groups transitioned to paddle blade propellers. The 4th Fighter Group received theirs in early February. The 78th Fighter Group completed transition by mid-month. By the end of February, 6 of the 8 Thunderbolt groups in England flew paddle blade-equipped aircraft. Each group immediately saw improved combat effectiveness. German fighter losses climbed as Luftwaffe pilots found their standard escape tactics no longer worked. On the 21st of February 1944, Jagdgeschwader 26 lost 7 Focke-Wulf 190s in a single engagement with the 56th Fighter Group. The unit commander, Major Klaus Mitusch, filed an after-action report that revealed growing frustration. His pilots had engaged according to established doctrine, disengaging through climbing attacks when pressed by superior numbers. Every pilot who attempted this maneuver was shot down. Mitusch requested immediate clarification on whether the Americans had introduced a new fighter type and whether existing tactical doctrine remained valid. Luftwaffe intelligence had no satisfactory answer to provide. German understanding improved through continued observation and analysis of wrecked aircraft. By March, Luftwaffe intelligence recognized that American engineers had modified the Thunderbolt's propeller to improve thrust at low airspeeds, particularly during climbs. Reports circulated throughout fighter units warning that American fighters could now contest vertical combat, recommending engagement only when holding a clear energy advantage and disengaging through level high-speed flight rather than climbing escapes. But changing tactical doctrine across hundreds of fighter squadrons proved impossible to accomplish quickly. Pilots who had survived for the past year by climbing away couldn't instantly reprogram their survival instincts. The scale of the transformation became undeniable during Big Week, the massive bombing campaign against German aircraft production facilities in late February. From the 20th to the 25th, the 8th Air Force launched over 3,800 bomber sorties, escorted by more than 1,600 fighter sorties. The vast majority of American fighters were paddle-blade-equipped P-47s. The Luftwaffe launched over 2,000 sorties in defense. The Germans lost approximately 355 fighters destroyed, with another 100 damaged beyond repair. American fighter losses totaled 28 aircraft. The exchange ratio had shifted dramatically in favor of the Americans. Thunderbolt pilots discovered that paddle blade propellers created opportunities beyond simple climb performance improvement. Increased thrust at low speeds improved acceleration out of dives, allowing Thunderbolts to build energy faster after high-speed attacks. Pilots could execute repeated dive and climb attacks, maintaining initiative throughout extended engagements. Improved thrust also enhanced turning performance at slower speeds. While Thunderbolts still couldn't outturn Messerschmitt 109s or Focke-Wulf 190s in flat horizontal turns, they could maintain sufficient energy in climbing turns to prevent German fighters from gaining angular advantage. Major Francis Gabreski, commanding the 61st Fighter Squadron within the 56th Fighter Group, became the leading proponent of what pilots called the climbing spiral. Gabreski would engage a German fighter at co-altitude, typically around 24,000 feet. Rather than attempting to outturn the enemy horizontally, he would maintain speed and pull into a climbing turn. German pilots, seeing the Thunderbolt climb, often followed expecting the American fighter to lose energy and become vulnerable. But with paddle blade propellers P-47s maintained climb rate even while turning. Gabreski would spiral upward through 2 or 3 full circles, gradually reducing the German fighter's energy state until the enemy stalled or was forced to break off. At that moment, with the German fighter at low speed and high altitude, Gabreski would reverse, dive onto the target and open fire from a position where the enemy had no escape route. Gabreski ultimately claimed 28 aerial victories flying P-47 Thunderbolts, making him the leading American ace in Europe flying a single aircraft type. Nearly all these victories came after his squadron transitioned to paddle blade propellers. In interviews conducted after the war, Gabreski consistently credited the new propeller as the single most important factor in the P-47's transformation from adequate to outstanding. The modification required minimal changes to pilot training. The aircraft simply did what pilots wanted it to do, maintaining energy in situations where narrow blade-equipped Thunderbolts would have failed. The paddle blade program represented American industrial capability operating at peak efficiency. From initial concept to widespread deployment required only 9 months. Two companies designed, tested, and began manufacturing two different propeller designs simultaneously. Republic Aviation modified production lines at two factories. The Army Air Forces developed new maintenance procedures, trained mechanics, and shipped thousands of propellers across the Atlantic. No single aspect was revolutionary or unprecedented. The achievement lay in the speed and scale of implementation. The United States identified a critical deficiency in a frontline weapon system and corrected it faster than Germany could develop effective countermeasures. German aircraft designers possessed the technical knowledge to create similar improvements. Both Messerschmitt and Focke-Wulf employed experienced propeller engineers who understood the theoretical benefits of increased blade area. But the German war economy in 1944 could not support rapid modification programs. German aircraft production operated at maximum capacity, focused on producing existing designs in sufficient quantities to replace mounting combat losses. Introducing new propeller designs would require retooling production lines, recertifying aircraft performance, updating maintenance manuals, and training mechanics. The production disruption would cost thousands of aircraft at a time when Germany desperately needed every fighter it could produce. American engineers took a pragmatic approach that prioritized rapid deployment over theoretical optimization. The paddle blade propeller wasn't perfect. It created more drag than narrower blades at high speeds. It was heavier, requiring reinforced hubs and pitch control mechanisms. But it solved the immediate problem without requiring years of development to optimize every parameter. German designers often pursued theoretical perfection at the expense of practical implementation. German propeller designers worked on advanced variable pitch systems that would theoretically outperform the crude American paddle blades. But these advanced designs existed primarily on paper, never reaching operational service in meaningful numbers. By March of 1944, the paddle blade Thunderbolt had become the standard American escort fighter in Europe. The aircraft was no longer a compromise platform awaiting replacement by longer-ranged P-51 Mustangs. The Thunderbolt had evolved into a formidable air superiority fighter capable of dominating German opponents in most combat situations. The psychological impact was significant and measurable. American bomber crews, who had watched helplessly throughout 1943 as German fighters climbed away from pursuing escorts, now saw enemy fighters chased down and destroyed in climbing combat. German pilots, already demoralized by increasing American numerical superiority, faced an attack in a tactical environment where their advantages had been neutralized. The Focke-Wulf 190, designed to be superior to the Thunderbolt in nearly every performance category, found itself matched or exceeded in the one area where it had maintained clear superiority. The Messerschmitt 109 could no longer rely on vertical maneuvers to escape combat. German fighter losses climbed steadily through the spring of 1944. Many veteran pilots who had survived years of combat were shot down by Thunderbolts they thought they had successfully evaded. The full impact became evident during preparations for the invasion of France. Throughout May, American fighters conducted intensive operations aimed at achieving air superiority over northern France. Thunderbolts ranged across the occupied territory, attacking German airfields, destroying aircraft on the ground, and engaging any Luftwaffe fighters that attempted interference. The paddle blade-equipped P-47s proved especially effective in these fighter sweeps. When German fighters scrambled to intercept, they typically climbed from lower altitudes to reach American fighters operating at 20 to 25,000 feet. Thunderbolts could now dive on these climbing German fighters, attack, then climb away before the Germans could retaliate. On the 6th of June 1944, as Allied forces stormed the Normandy beaches, Thunderbolts provided air cover throughout the day. German fighters that attempted to attack the invasion fleet or support German ground forces were consistently intercepted and destroyed by paddle blade-equipped P-47s. The Luftwaffe managed fewer than 100 sorties over the invasion beaches during the critical first 24 hours. American fighters flew more than 8,700 sorties during the same period. This overwhelming superiority was possible because American fighters achieved kill ratios of 4-to-1 or better. The paddle blade propeller, by eliminating the Thunderbolt's primary weakness, contributed directly to achieving the air superiority that made the invasion possible. Statistical evidence supported what pilots experienced in combat. In the first quarter of 1944, before paddle blade propellers became widespread, American fighters in Europe achieved an overall kill ratio of approximately 1.8-to-1 against German fighters. By the second quarter, with most American fighters equipped with paddle blades, the kill ratio improved to 3.2-to-1. By the third quarter, it reached 4.6-to-1. These improvements cannot be attributed solely to the propeller modification. American numerical superiority was increasing, pilot training was improving, and Germany was fielding inexperienced pilots to replace mounting losses. But combat reports make clear that improved climbing performance played a significant role in these victories. The Curtiss electric propeller, designated C542S and representing the most widely used paddle blade variant, featured 4 blades with a 13-foot diameter. Each blade had significantly increased area compared to narrow blade predecessors. The chord, meaning the width of the blade measured from leading edge to trailing edge, increased substantially. This created much greater surface area for the blade to push against the air during each revolution. The Hamilton standard propeller used a hydraulic pitch control system that was simpler and more reliable than the Curtiss electric system. Total blade area was nearly identical between the two designs, and combat performance was indistinguishable to pilots. Manufacturing effort required to equip the P-47 fleet demonstrated American industrial capacity operating at impressive scale. Both Curtiss-Wright and Hamilton Standard produced thousands of propeller assemblies between June of 1943 and December of 1944. Each assembly consisted of 4 blades, hub assembly, pitch control mechanism, and mounting hardware. Blades were forged from aluminum alloy, machined to precise airfoil shapes, and heat-treated for maximum strength. Each blade required approximately 14 hours of machine time, not including raw material preparation and finishing operations. Distributing these propellers to operational units in England presented significant logistical challenges. Each assembly weighed approximately 650 pounds and required careful handling to prevent damage during shipping. Propellers were packed in wooden crates with protective bracing and shipped across the Atlantic on cargo vessels. Voyages typically required 2 weeks under wartime conditions with convoy routing and submarine threat considerations. Upon arrival, propellers were transported to air depot facilities where mechanics installed them on aircraft. Installation required approximately 16 hours per aircraft, including removal of old propellers, installation of new ones, rigging pitch control systems, and conducting ground tests to ensure proper operation. Between January and June of 1944, air depot mechanics in England retrofitted over 1,000 Thunderbolts while maintaining operational readiness of frontline fighter groups. This represented a remarkable feat of logistics and maintenance coordination. Tactical evolution of paddle blade Thunderbolt operations continued through summer and fall of 1944 as pilots developed increasingly sophisticated techniques to exploit the improved climbing performance. One particularly effective tactic was the vertical scissors, where 2 Thunderbolts would engage a German fighter in a climbing dogfight. As the enemy aircraft climbed to escape one P-47, the second would position to attack as soon as the German fighter lost energy and could no longer climb effectively. The German pilot faced an impossible choice: continue climbing until stalling, making himself an easy target for the trailing Thunderbolt, or roll out to maintain airspeed, allowing the lead Thunderbolt to execute a diving attack. Another significant development was the use of paddle blade Thunderbolts for low-altitude ground attack missions. Improved thrust at low speeds allowed heavily loaded P-47s to maintain speed and maneuverability, even when carrying 2,500 pounds of bombs or rockets. Pilots attacking German ground targets could enter attack dives from lower altitudes, reducing exposure time to anti-aircraft fire. After delivering ordnance, paddle blade-equipped Thunderbolts could climb away from target areas more rapidly, again reducing vulnerability to ground fire. Between April and September of 1944, Thunderbolts flew more than 88,000 ground attack sorties, while suffering approximately 820 losses to all causes, representing a loss rate of less than 1%. The versatility of paddle blade Thunderbolts allowed them to remain in frontline service even as longer-ranged P-51 Mustangs became available in increasing numbers. Many fighter groups chose to retain Thunderbolts specifically because the improved performance made them exceptionally effective in multiple roles. The 56th Fighter Group, commanded by Colonel Hubert Zemke and later Colonel David Schilling, flew Thunderbolts exclusively throughout the entire war, despite opportunities to transition to Mustangs. The group's pilots believed the rugged construction and 8-gun armament, combined with excellent climbing performance provided by paddle blade propellers, made the Thunderbolt superior to the Mustang for their style of operations. German fighter pilots who survived the war consistently mentioned the paddle blade Thunderbolt as one of the most capable American fighters they faced. Major Gunther Rahl, who survived the war with 274 victories primarily achieved on the Eastern Front, noted in post-war interviews that improved Thunderbolts were far more dangerous than earlier versions. Rahl stated that German pilots had to treat paddle blade Thunderbolts with the same respect they accorded P-51 Mustangs, recognizing the American fighter could match German performance in most combat situations. Engineering lessons learned from the program influenced American aircraft development throughout the remainder of the war. The rapid development and deployment demonstrated that incremental improvements to existing aircraft could often provide better value than developing entirely new types. The P-47 itself benefited from continued improvements beyond propeller modification. Water methanol injection systems increased engine power to 2,535 horsepower for short periods. When combined with paddle blade propellers and their improved thrust characteristics, this further enhanced performance. The P-47M, introduced in late 1944, incorporated both modifications and could climb rapidly, matching or exceeding the climbing performance of any German fighter then in service. The financial investment required to develop and deploy paddle blade propellers was modest compared to the operational benefits achieved. Development costs for both Curtiss and Hamilton standard propellers, including wind tunnel testing, prototype construction, and flight testing, totaled approximately $3 million. By comparison, developing an entirely new fighter aircraft would have cost at least $100 million and required 2 to 3 years before reaching operational service. The paddle blade propeller represented exactly the kind of cost-effective improvement that made American air power difficult for any adversary to match. Paddle blade propellers also highlighted the importance of feedback loops between combat operations and aircraft development. Problems with narrow blade propellers were identified by frontline pilots who filed after-action reports describing German fighters escaping through climbing maneuvers. These reports filtered through intelligence systems to reach engineers who could diagnose root causes and develop solutions. This feedback loop operated relatively quickly, with problems identified in combat leading to engineering solutions within months. German forces had similar feedback systems in theory, but found them increasingly disrupted by the chaos of Germany's deteriorating strategic position. Strategic impact extended well beyond direct air combat results. Achievement of air superiority over Europe, to which improved Thunderbolts contributed significantly, allowed Allied ground forces to advance with minimal interference from German air power. During the breakout from Normandy in August of 1944, American ground forces advanced under an umbrella of air superiority maintained largely by Thunderbolts. German ground forces attempting to retreat or reposition found themselves under constant attack from Allied fighters. Improved climbing performance meant German fighters that attempted to interfere with ground attack missions could be quickly intercepted and destroyed by escorting P-47s. The final major air combat involving large numbers of paddle blade Thunderbolts occurred during the Battle of the Bulge in December of 1944-44 and January of 1945. when German ground forces launched a surprise offensive through the Ardennes. Bad weather initially prevented effective air operations. When weather cleared on the 23rd of December, Allied air forces launched massive attacks against German ground forces and supply lines. Paddle-blade-equipped Thunderbolts flew hundreds of sorties daily attacking German armour, trucks and artillery positions. Luftwaffe fighters attempted to interfere, but were consistently driven off by escorting P-47s that could now match them in vertical combat. By February of 1945, organised Luftwaffe resistance over Western Europe had effectively ceased. German fighter units were being withdrawn to defend the homeland against the increasing strategic bombing campaign. Paddle-blade Thunderbolts had played a significant role in achieving this air superiority, though their contribution was overshadowed by the more glamorous reputation of P-51 Mustangs in popular accounts. Military historians examining the air war have sometimes downplayed the Thunderbolt's importance, noting that P-51s achieved more aerial victories and flew deeper into Germany on escort missions. But this misses the critical point that the Thunderbolt's transformation through paddle-blade propeller modification came at a crucial moment when German fighter forces still represented a formidable threat. Between January and December of 1944, Thunderbolts were credited with destroying 3,082 German aircraft in aerial combat, while losing 824 P-47s to all causes in the European theatre. This represented an overall kill ratio of 3.7 to 1, comparable to or better than other American fighter types during the same period. More importantly, the Thunderbolt's transformation from mediocre climber to capable vertical fighter occurred during the period when such capability was most desperately needed. The post-war fate of paddle-blade Thunderbolts reveals how quickly wartime innovations can be forgotten when new technologies emerge. As jet fighters entered service, propeller-driven P-47s quickly became obsolete regardless of their wartime achievements. Most surviving Thunderbolts were scrapped or sold to foreign air forces. Technical achievements that made paddle-blade Thunderbolts effective fighters were eclipsed by the revolutionary capabilities of jet propulsion. Few pilots who flew improved Thunderbolts in combat went on to positions where they could ensure the propeller modification received proper historical recognition. Yet paddle-blade propellers represent a fundamentally important type of military innovation that deserves greater recognition than it typically receives. It was not a revolutionary breakthrough that changed the fundamental nature of air combat. It was an evolutionary improvement that took an existing platform and eliminated its most critical weakness through relatively simple engineering modifications. This type of innovation, less dramatic than revolutionary new technologies but often more immediately impactful, characterized much of American military success during the Second World War. The ability to identify problems, develop practical solutions, implement those solutions rapidly, and deploy them at scale gave American forces decisive advantages across multiple domains. Engineering principles underlying paddle-blade propellers remain relevant to modern military aviation, despite the transition to jet propulsion. The fundamental insight that blade area must be optimized for intended operating conditions rather than theoretical maximum efficiency applies to turbine blade design, helicopter rotor design, and unmanned aerial vehicle propulsion systems. Military engineers still face the challenge of balancing multiple performance requirements across different flight regimes. The German perspective on paddle-blade Thunderbolts provides sobering lessons about the consequences of industrial and strategic weakness. German engineers understood propeller theory as well as their American counterparts. German aircraft factories were capable of producing improved propellers had they been given the resources and opportunity. But Germany's deteriorating strategic position, resource shortages, and increasingly disrupted industrial base made rapid improvement programs impossible to implement. Paddle-blade Thunderbolts succeeded not because American engineers were more skilled than German engineers, but because American industry could support rapid innovation, while German industry could not. Wars are not won by single wonder weapons or brilliant strategies or revolutionary technologies alone. They are won by the accumulated weight of thousands of incremental improvements, each addressing specific problems, each implemented efficiently, each contributing to overall superiority. The paddle blade propeller was one such improvement among many.